It is time for me to show you how to evaluate a definite integral when you're doing u-substitution. There are two different methods that you could use. I think I'll do one method on number 56 and I'll do the other method on number 60. So the method that I usually do is the one where you just ignore the limits of integration and do your u-substitution and solve the entire problem as an indefinite integral, and then put the limits back in. If you're going to use this method, it's very important that you do not write down the limits of integration until the end of the problem. So I'm going to go ahead and do my u-substitution. Obviously, we have this expression inside the parentheses. That's probably going to be the u. So let's let u equal 2x to the fourth power plus 1. That means u prime is going to equal 8x to the third power. Let's go ahead and do the substitution. But like I said, as I write this down, I'm going to very carefully avoid writing down the 1 and 0. The reason why is because these are x's. This is an x. X equals 1, x equals 0. So as soon as we replace all these x's with u's, then these will be the wrong limits of integration. So there is a way to change them to the correct limits that are in terms of u, and that's what I'm going to do on the next example. But for now, just leave them off. If you put 0 and 1 here, you will get the problem wrong on the AP exam. So here we go. For now, we will have our x to the third power, but then we have u squared. I guess I don't need parentheses on this. So we have u squared. Instead of dx, we will write du divided by u prime, which is 8x to the third power. Let's see what cancels out. The x to the third power cancels out this x to the third power. Notice we have this 8 in the denominator. That is 1 over 8 out in the front. And then we have our u squared du. We can easily integrate this with the power rule. Add 1 to the exponent and we have u to the third power. Divide by the new exponent, so we have 1/3. Bring down that 1/8. Let's go ahead and get the x's back in. So we will have 1 over 24 times 2x to the fourth power plus 1 cubed plus c. So we found the indefinite integral. But now it's time to suddenly remember that this is a definite integral from 0 to 1. So let's come back up here and rewrite this with one small change. 2x to the fourth power plus 1 cubed. Instead of the plus c, let's put that vertical line with the constants of integration. Now that we have the x's back, it's safe to put our original limits of integration. And of course, we will evaluate at the upper limit and then subtract the value at the lower limit. So let's see. Starting with the upper limit, we have 1 over 24 times 2 times 1 to the fourth power plus 1 cubed. So there's the upper limit. Now we subtract the value at the lower limit. So we have 1 over 24 times 2 times 0 to the fourth power plus 1 cubed. So what do we have? Well, first of all, technically this is an answer to the question. So let me be clear that if this was a free response question, you are free to leave your answer just like this and get full credit. But because of possible multiple choice questions, I'm going to keep going and simplify this a little bit more. So let's see. We have this 1 over 24. 1 to the 4th power is 1. So then we just have 2 plus 1, so that's 3 to the 3rd power. And in here we have 0. 2 times 0 is 0. That's going to be 1. So we have 1 to the 3rd power, still 1. So we really just have 1 over 24. 3 to the 3rd power is 27. So this is going to be 27 over 24 minus 1 over 24, which is 26 over 24, which in turn reduces to 13 over 12. So this is a simplified version of the final answer. So here is another definite integral, but this time I'm going to use the method where when I do the substitution, I will actually change the limits of integration to match the new variable. So probably the u will be this stuff inside of the radical. So let's let u equal 1 plus 2x squared. So what about u prime? U prime will be 4x. Let's go ahead and do the substitution. But we're going to have to change the limits of integration as well. But I'll get to that in a second. For now, we have x over, and we have the square root of u. Instead of dx, we put du over u prime, which is 4x. We notice that we have an x here in the denominator, which will cancel out the x in the numerator. In a moment, when I rewrite this, this 4 will come out in the front as a 1/4. But it's time to deal with the limits of integration. Please remember that these right now are x's. Okay, this is an x value, x equals 2. This is another x value. We want these to now become u. All right, this needs to be a u instead of an x. This needs to be a u. So how do I do that? Well, we have a formula for u right here. All right, this formula will convert x's into u's. So let's start with 2. Let's find u. I'll call it u at 2 will equal 1 plus 2 times 2 squared. So u at 2 is going to equal, well, 2 squared is 4. 2 times 4 is 8, plus 1 is 9. So instead of 2, we should have a 9. Now let's go ahead and do u at 0 and see what that is. So let's see, u at 0 would equal 1 plus 2 times 0 squared. Well, this term will be 0, and then we just have the 1. So u at 0 is equal to 1. So instead of a 0, we should have a 1. One cool thing about this method is that once you have changed the limits of integration, you do not have to switch back to x's later. So anyway, we have the integral from 1 to 9, and this 4 in the denominator will become a 1/4 out in the front. The square root of u is the same as u to the 1/2 power. because it is in the denominator, we will write u to the negative 1/2 power du. Using the power rule of integration, we add 1 to this exponent, and we end up with positive 1/2. Then we divide by the new power. Dividing by 1/2 is the same as multiplying by 2. Let's not forget about the 1/4 that we still have out there in the front. And it's time to evaluate at the limits of integration from 1 to 9. Actually, let's go ahead and simplify this a tiny bit. Of course, 1/4 and 2 simplifies down to 1/2. So we actually have 1/2. Maybe I'll go ahead and put the square root of u at this point while I'm at it. So we have 1/2 the square root of u being evaluated from 1 to 9. So of course, we start with the upper limit, and then we subtract the value at the lower limit. So that will be 1/2 times the square root of 9 minus 1/2 times the square root of 1. So square root of 9 is 3, so we have 3 over 2. By the way, I should say that we could stop here. This is an acceptable answer. I'm going to keep going in case we are looking at a multiple choice problem. So we have 3 over 2 minus 1/2, which is just going to be 2 over 2, which is actually just 1. See, aren't you glad we went ahead and simplified this? Isn't that so much nicer than this ugly expression? But either one is honestly fine. Before I move on, I want to emphasize one more time. Notice that I never did substitute 1 plus 2x squared back in for u. That's because we changed the limits of integration. Instead of 2 and 0, which were x values, we switched over to 9 and 1, which are u values. So we did not have to switch over. We could just go ahead and evaluate using u. Here is another definite integral. This time I'm going to go back to the method where we switch back to x's. So what will the u be? Probably the stuff inside the radical. So let's let u equal 2x minus 1. Now u prime will be just 2. Let's go ahead and do the substitution. However, I do not want to change the limits of integration. So do not write them down at all. We're doing the indefinite integral temporarily. So we have x over the square root of u. Instead of dx, we will write du over u prime, which is 2. So, all right, this is one of those problems where the x does not cancel out. So we're going to have to deal with that. Let me go ahead and bring this 2 out to the front as a 1/2. So I have 1/2 integral of x over the square root of u du. So let's deal with this x. Rewriting this, let's solve this for x. Adding 1 to both sides, we have u plus 1 is equal to 2x. Dividing everything by 2, we're going to end up with 1/2 u plus 1/2 is equal to x. So this is an expression that I can substitute for x. Let's go ahead and do that right now. So I have 1/2 integral of 1/2 u plus 1/2. In the denominator, instead of square root of u, I will go ahead and put u to the 1/2 power and then du. See, do I have any more space down here? Kind of. So yeah, I can squeeze one more line in here. Remember that when I divide with variables, I subtract the exponents. So see that 1/2 right here? I'm just bringing that down. But 1 minus 1/2 is 1/2. So I'm going to have u to the 1/2 power plus. Okay? Now I'm also going to divide 1/2 by u to the 1/2 power. This 1/2 is just going to come down. And this u to the 1/2 power is going to become u to the negative 1/2 power. Okay, again, I'm using that property where if I have a plus b over c, I can rewrite this as a over c plus b over c. So that's what I just did. Okay, we can integrate each of these terms separately. So I still have my 1/2 out in the front, but inside of here I'm doing the power rule. So adding 1 to this, I'm going to get 3/2. So I have u to the 3/2 power. And then you divide by the new power, which becomes the reciprocal 2 over 3. But I had a 1/2 sitting there, so I still have this 1/2. I will deal with that later. Moving on to the next term. Adding 1 to negative 1/2 gives me positive 1/2. Then you divide by the new power, which becomes the reciprocal, which is a 2. But then I still had 1/2 that's in front of there, so that'll be nice later. Okay, so that's it for that. I need the plus c because I'm still doing the indefinite integral for now. Let's simplify a little bit. So I have 1/2 times, these twos cancel out, so I have 1/3 u to the 3/2 power. These twos cancel out, so I just have u to the 1/2 power plus c. Okay, I am doing the method where I am leaving the original limits of integration. So I need to go back to x's. So this is going to be a long expression, but what are you going to do? So I have 1/2. Okay, here come the x's. Instead of u to the 3/2 power, I'm going to put, I should be focusing on this. I'm going to put 2x minus 1 to the 3/2 power. And then I have 2x minus 1 to the 1/2 power. Okay, and all of that is plus c. So that is it for the indefinite integral. But now that I have the x's back, I can go ahead and evaluate using my limits of integration. So I'm going to go ahead and remember that the limits of integration are 1 and 5. So I need to evaluate this from 1 to 5. So I set up the value at 5, and then I'm subtracting the value at 1. So this crazy long expression doesn't even fit on the screen all the way, but please understand that this would actually be an acceptable answer for a free response question on the AP exam. You could just leave this whole thing just like this. But just in case we do have a multiple choice question, I am going to go ahead and simplify this as much as possible. So let's see what we have. So I've got 1/2, and then I've got 1/3 times. This will be 10 minus 1, so that'll be 9 to the 3/2 power. And this is 9 to the 1/2 power minus 1/2 times 1/3. Okay, and this is just 2 minus 1, so that is 1 to the 3/2 power, and then plus 1 to the 1/2 power. So it seems like this will simplify pretty nicely. Remember, when you do 3/2 power, this is power over root. So we're going to do the square root and then we're going to cube it. So let's see if we can follow this through. So I still have my 1/2 out there, and I'll keep my 1/3 for another minute. The square root of 9 is 3, but then cube that and you've got 27. Alright, so that's 9 to the 3/2 power. Of course, the square root of 9 is 3, so that's 9 to the 1/2 power. Alright, what's going on over here? Well, we have the 1/3. 1 to the 3/2 power is just 1, so that's gone. And then 1 to the 1/2 power is just 1, so we have this. So 1/2. 1/3 of 27 is 9. And let's see, so this would be the same thing as 1/3 plus 3 over 3. I'll just get ready there. So I have 1/2 times 12 minus 1/2 times 4 over 3. Alright, half of 12 is 6. Half of 4 over 3 is 2/3. Okay, like denominators, 6 is the same as 18 over 3. So it's really 18 over 3 minus 2 over 3, which is 16 over 3. So this is the fully simplified answer. Of course, we could have stopped at any step along the way of the simplification process. Before we do this last problem, let me remind you of the rules. Remember that the derivative of secant was secant tangent. And then remember that the derivative of cosecant was negative cosecant cotangent. So, reversing this, we remember that the integral of cosecant cotangent will be cosecant, plus c, obviously. So why am I mentioning this? Look at the problem that we have. Notice that we have this cosecant cotangent pattern. So we will need the fact that the integral of cosecant cotangent is cosecant. Keep that in mind. Let's do our u-substitution. Probably best to let our u be the stuff that is inside of these trig functions. So let's let u equal 2x. In that case, u prime will simply be 2. When you do the substitution, do not write down the limits of integration, because we're going to use the method where we switch everything back to x's later. So let's go ahead and write cosecant u cotangent u. Instead of dx, we write du over u prime, which is 2. So this 2 is going to end up out in the front as a 1/2. So we have 1/2 integral of cosecant u cotangent u du. Again, please remember, when you do your u-substitution, do not write down the original limits of integration. These are x's, and we now have u's, so they don't match. If you write pi over 12 and pi over 4 on this step, you will at least lose a point on the AP exam. As I reminded you a moment ago, the integral of cosecant cotangent is negative cosecant. So we will have negative 1/2 times cosecant u plus c. Let's get the x's back in here. So we have negative 1/2 cosecant of 2x plus c. So that is the indefinite integral, but let's remember that we are actually evaluating the definite integral from pi over 12 to pi over 4. So let's get the limits of integration back in here. So we have negative 1/2 cosecant of 2x evaluated from, what did I say, pi over 12 to pi over 4. So pi over 12 to pi over 4. This means we will find the value at the upper limit and subtract the value at the lower limit. Let's start with the upper limit. So negative 1/2 cosecant of 2 times pi over 4. Now let's subtract the value at the lower limit. Negative 1/2 cosecant of 2 times pi over 12. Okay, by the way, you can't stop here. While you don't need to simplify, you always must evaluate trig functions. So this would not be a valid answer. Let's see, negative 1/2 cosecant. 2 times pi over 4 reduces to pi over 2. And this is going to be addition. I'm going to go ahead and deal with the minus and negative aspect of it. But then we have 1/2 cosecant of pi over 6. Let's evaluate this trig function. Remember that cosecant is the reciprocal of sine. So keep that in mind. So what is the sine of pi over 2? Remember that pi over 2 is up here at the top of the unit circle. Sine is the y value. So the sine of pi over 2 is 1. That means the cosecant of pi over 2 is the reciprocal of 1, which is still 1. Okay, pi over 6. What is the sine of pi over 6? The sine of pi over 6 is 1/2. That means that the cosecant of pi over 6 will be 2. It's the reciprocal. So we have 1/2 times 2. So that makes negative 1/2 plus 1. So the final answer is positive 1/2.